Okay, so we have an urn, a big ass jar with 3 red skulls, a blue skull, and a crystal skull in it. Crystal, 2 blues, and 3 reds. Okay? And the Necromancer makes you draw 2 skulls without replacement. So you're going to pull 2 skulls out of here, or else he's going to kill you. He's probably going to kill you anyway, because that's how Necromancers roll. Okay, calculate the probabilities of the following. You draw 2 red skulls, and stuff happens to you. So, here at the beginning, right? How many options are there?
6.
Kinda.
6.
There's 3 red.
So there's 3 red skulls
Out of 6 marbles.
out of 6 total skulls, right? So in your first draw, right, there's either red, blue, or a crystal skull. You guys all see that?
Mm-hmm.
So if I'm drawing my tree, I'm going to go red, blue, crystal. Okay, then I want to know the probabilities along each edge. So, I'm doing this for the whole thing because I'm going to answer the whole question all at once.
So 1, 6, 2,
So,
6, and 3, 6.
One of the 6 things is a crystal skull. From the red,
2, 6, so 20, or 33, 23, 20.
wait, how many red skulls are there?
3. Whoops, I got blue.
So there's 3 and 6 skulls are red, and 2 and 6 are blue. You guys see that? Okay, then from each of these there are 3 options. Oh wait, no, that's not true. From the crystal skull there is only 2 options. From the other 2 there are still 3. Okay, so
Draw a crystal and a blue one.
crystal, oops, those are crystal and crystal in the second spot, and these guys are crystal, crystal. So this one's going to be crystal and then red. This one's going to be crystal and then blue. These 3 all started with a blue, and that one's going to end with a blue. And this guy's going to be red, 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 and red, then blue.
Wait.
Whoa.
Yeah, that just like,
Did I tweak you out?
yeah, yeah.
Okay, now I need probabilities. So for the first question, I really only care about this guy, right? The 2 reds. So that was red first was 3 and 6, and then the second one, how many balls are there left, or skulls are
How
there?
come there's not 3 options for the crystal one?
Because there's only one crystal.
Yeah, because there's only 1 crystal skull, right? So if you picked it first, then there's only red and blue left. You guys with that? So, how about red, red, the one I care about first? It's 3 and 6 for the first red one, and then how many red skulls are left?
2.
Yeah, there's 2 left because you took 1 out. And how many skulls total are there?
5.
5. So you multiply along the edges. This has 3 and 6 times 2 and 5 probability of happening.
6 out of 6.
You guys see that? So that's 6 over 30 is 1 over 5.
Yeah.
So part A on this question is 1 and 5.
For 20%.
So 20% of the time you're going to draw 2 red skulls and get smushed.
Wait, you're getting smushed?
That's what it says.
Creation.
Yeah, you get killed and made into his next skeleton or whatever. Okay, next thing. You draw at least 1 skull and are released. So, 1 blue skull. So where are the blue skulls?
Where? What do you do when you release it?
He lets you go. He's like, go.
You are released. You don't have to do none of this.
So what's the probability of you drawing?
Yeah, so what's the probability of drawing at least 1 blue? Well, 2 and 6 gets me
No way. You're free.
a blue, right?
You're done.
The other 3 and 6 and 1 and 6, those get me to,
One blue.
well,
2 and 5.
to not a blue, right? But then I have an option to get to a blue.
Just 2 and 5.
Do you guys see that? And in this case, there's 2 blues left out of 5. And in this case, there's
2 blues left out of 5.
2 blues left out of 5. You guys see that?
So 2 6 times 2 fifths times 2 fifths.
So my probability of at least 1 blue is the 2 and 6 for getting blue first, plus this guy.
Can you do 4 fifths? It's your plug.
I do 4 fifths.
We just combine the two fifths.
These two? They're getting multiplied by something else. So to get to this guy, you need to first do the 3 and 6 arrow to get a red, and then do a 2 and 5 arrow to get there. So you're going to have, either you drew a blue first right off the bat. Oops, and I said 2 and 5, and I should have said 2 and 6. Sorry,
I
that
have
was
a question.
just a typo.
So why can't you just do the fraction of, like, the outcomes? You know what I mean?
Like,
So why can't you just say, like, what would it be? 5 out of 8?
Oh, because they don't occur with even probability, right?
The outcomes?
These outcomes.
Yeah.
Let's see.
Why would, you know what I mean?
Yeah, because they don't occur with even probabilities. Because you're quite a bit less likely to draw this. So, of the outcomes listed here, right? 1, 2, 3, 4 of them include that crystal ball, right?
Yeah.
But that's still a really unlikely outcome. So it's because the arrows are weighted differently.
Okay.
It's not quite a coin toss, right? In the coin toss, you can get away with just counting up the outcomes.
Yeah.
In here, you have to calculate the weights of each one.
That makes sense.
So this guy here occurs 3/6 times 2 fifths of the time. And this guy down here occurs 1/6 times 2 fifths.
Yeah.
So my total is either you drew a blue at first, 2 and 6, or you drew a red first and then a blue, that's 3 and 6 times 2 and 5, or you drew the crystal one first and then a blue, that's 1 and 6 times 2 and 5.
Okay. I was just
What?
wondering. Is there, but if there were,
It's hard.
Yeah, this is a little tough, right? You gotta follow each edge down.
So you
if there
have to
were
make a tree.
3,
Yeah, you have to make a tree.
Do you?
Yes.
Come on.
No, you don't have to make a tree. You can reason this out, but it's hella hard. You
I put 1/3.
Is that a
so
tie?
if there were 3 red and
So,
3 blue.
1 in 3 is the probability of getting a blue ball at first, right? But then there's, after you draw a ball, you get the option, if you didn't draw a blue ball, you get a second draw that's gonna, what's that?
1/5.
But it's not 1/5, because there's 2 blue balls left.
You just drew a blue
You
ball.
have some kind of shortcut and get all the way around it and just go straight to the answer.
Nope.
I thought it was
Draw a
two-
tree.
I thought it was 2 6 2 6.
So it's 2/6
Yeah.
for drawing a blue ball
Release.
at first, right?
And then you're done. You drew a blue ball.
Yeah, and then you're done, right? So that's this one. You get to friggin' leave if you get that 2 and 6. If you don't get 2 and 6, you either drew a red one or a crystal one,
Well, we're just gonna act like we did.
right?
Okay.
From the red one, you have a 2 in 5 chance of drawing a blue on your second go, right? So that's, you had to get to a red and then draw a blue.
But you also have to do it. Did you just do that acting like you didn't get a blue ball or acting like you did get a blue ball at first?
So this one is red first, then blue, and this one's
Then what,
crystal
you just have
first,
to find a
then
common
blue.
The only time you got a blue ball
together?
first was the 2 6.
Yeah.
And the second time you got a red ball, you got the red ball. Now with a chance you're gonna get a blue ball after that.
Yep.
And then, same thing for third.
Wait, why'd
Yep.
you do it? Why'd you do it on the bottom?
Why did I do what on the bottom?
Why?
Okay.
So why are you adding those, multiplying and then adding? I think I looked down and I might have missed it.
Okay, so let me dump my work from earlier.
110?
For some reason the tree doesn't help.
Okay, so let me make full use of the tree,
Okay.
and maybe that'll help, because I'm kind of partially using the tree, and I think it's getting a little confusing. So if I label all of the edges here,
Okay.
so what's this edge's weight? It's for drawing a red ball after you've drawn a crystal. So how many red balls are left in the urn?
3.
3?
3/5.
And there are 5 total balls. So, how about this one? This edge, I don't have weighted.
So 3, 6.
How many
2.
crystal balls are there?
2.
1.
There's 1, and there's 5 total balls, so that's a 1/5 edge.
Oh, I'm done. I'm so.
That's after you choose a red one first, right?
Yep. So after you choose a blue one first, how many crystal balls are there?
1.
1 left. And how many total balls are left?
5.
5. So that's a 1/5 edge there. After you choose a blue ball, how many red balls are left?
3.
3
3/5.
out of the 5. After you draw a blue ball, how many blue balls are left?
1.
Only 1 in 5.
1 blue ball.
You guys with this? Okay? And then you multiply. So you got 2 in 6 times 1 in 5. That's the probability of ending up at double blues.
Why would you even draw another blue one?
Because you have to.
Because you can.
Because he's going to make you draw 2. If he's going to let you go, he probably doesn't care. But whatever. So,
Like this game doesn't work out.
this guy, what's the weight, what's the probability of drawing a blue ball and then a red ball?
2, 6, 3,
2 6 times 3/5. This guy?
2 6 times 1/5.
2 6 times 1/5. This guy?
6 times 2/5.
3 6 times 2/5. This guy's 3 6 times 2/5. This guy's
1/5.
3 6 times 1/5. This guy?
I'm tapping out.
1
Yeah,
6
1/6
times 2
2/5.
fifths.
1 6 times 2/5. And last guy?
1 6 times 3 fifths.
Okay, so once you have the ends of the tree, what you can do is just count up all the ones you wanted, right? The blue ones. Be like, alright, which ones have a blue in them?
Why don't you add them all?
Yeah, and then you add them all together.
Holy, but you have
So
to get
check,
all.
check, check, check. Those ones, all added together.
Yeah.
Screwed.
And that'll give you the thing I just had on the board. Because
Is it 1 in 10?
this is 2 6 times 1 in 5 plus 3 in 5 plus 1 in 5 is 2 6 times 5 in 5.
Wait, if you multiply them, they all have the same denominator then?
Yeah, they'll all have a denominator of 30
Oh
here.
my god, dude, I thought
Right,
you
so you
were
can
gonna
just-
have to get common denominators for all of them.
No, no common bottoms required. They already have common bottoms.
Okay,
Dude, I still struggle with
Okay,
so
so
if
Okay,
there were 3 blue and 3 red, is that when you could use the results as a, like just,
just like counting.
yeah,
If there were 3 red and 3 blue and you were drawing with replacement, yeah,
okay.
it's the without replacement.
It's the
that makes it.
replacement, so would it be the same if you were it wouldn't be the same though if you were replacing the crystal one? Because, okay, that makes sense.
You guys all good with that?
Wait, your video?
I feel like the
Okay.
crystal one would be special. That's what I would do.
So, last question.
Wait, we never did.
The last question is, you draw a red and a crystal skull and get made into a necromancer. So where are the two with a red and a crystal?
And the third from the bottom?
Yep, so the ones with the red and the crystal are this one and that one.
So you add those
So that
together.
would be 3 and 30 plus 3 and 30
Yeah, I didn't know.
is a grand total of
9 and 1. Oh god.
3 and 30 plus 3 and 30 is a grand total of 6 and 30 or 1 and 5.
What was the answer to the other one?
The other one
Yeah.
Yeah, can we get one pass? Like,
is 2 plus 6 plus 2 is 10. Plus 6 plus 2 is 18 and 30.
Is there a way to do this without the tree?
Wait, so it's literally one,
Yeah, but it's a lot harder.
it's 110?
This is more complicated to me.
Not really, it's just.
The answer is
The
110?
the other thing's harder. So the other way you could do this is you could say, okay, so the probability of getting a red ball first times the probability of getting a black ball, and then you have to remember, or a crystal ball, and then you have to remember that getting a crystal ball first and then getting a black ball needs to be counted, and you add the probabilities. You can do that.
Is there another video that I can watch to help me with that? You might not.
Yeah, I think I have some examples.
Okay.